Compound interest is the interest calculated on both original or principal value and on the accumulated past interest. This is the main difference between compound and simple interest. In compounding, after the interest is calculated, the added amount to the principal and becomes an adjusted principal. Processes are repeated until the end of the loan or investment term. Normally used with long-term loan or investment, and the interest is calculated more than once during the loan or investment term. The interest earned or changed is called compound interest amount, and the final sum at the end of the period of investment or loan is called compound amount. Terms and their symbol. Original principal stand for P, nominal interest rate stand for K, interest period stand for T, frequency of conversion stand for M, predict interest rate stand for I, number of interest periods stand for N, future value or accumulated amount stand for S, and interest amount stand for I. The list of formula, there are 5 of them, which is S equals P multiplied by 1 bracket 1 plus I close bracket raised to the power of N. Formula 2, interest equals the accumulated amount minus the principal amount equal. Formula 3, P equals S divided by open bracket 1 plus I close bracket raised to the power of N. And the last formula is P equals S multiplied by open bracket 1 plus I close bracket raised to the power of negative N.
RM28,007.25 was borrowed from a bank with the interest rate charge of 6% compounded every 4 months. After 3 years, the maturity amount of the loan was RM42,449.65. Find the value of T and the amount of interest charged. First of all, for this question, we are given the principal amount where P equals RM28,007.25. The accumulated amount S equals 42,449.65. The annual interest rate K equals 0.06 while M equals 3, indicating that the interest is compound 3 times per year. However, the value of T, which represents the investment period in years, is unknown and needs to be determined. To begin with, we use the compound interest formula. S equals P multiplied by open bracket 1 plus K over M close bracket raised to the power of MT. Next, we substitute the given values. 42,449.65 equals 28,007.25 multiplied by open bracket 1 plus 0.06 over 3 close bracket raised to the power of 3t. Then, we simplify 0.06 divided by 3 to obtain 0.02. Therefore, 42,449.65 equals 28,007.25 multiplied by 1.02 raised to the power of 3t. Next, we divide both sides by 28,007.25 to isolate the exponential term. This gives 1.5157 equals 1.02 raised to the power of 3t. Since t is the exponent, we take the logarithm of both sides. Log of 1.5157 equals log of 1.02 raised to the power of 3t. Using the logarithmic rule, log of 1.5157 equals 3t multiplied by log of 1.02. Then, divide both sides by log of 1.02. 3t equals log of 1.5157 divided by log of 1.02. After calculation, 3t equals 21. Therefore, t equals 21 divided by 3, which equals 7 years. We calculate the interest earned using I equals S minus P. Substituting the values, I equals 42,449.65 minus 28,007.25. Hence, I equals 14,442 ringgit and 40 cents. In conclusion, the investment period is 7 years and the total interest earned is 14,442 ringgit and 40 cents.
For question 2b1, 4 years ago, Isma had a fund worth 50,000 ringgit and was invested in a financial scheme that pays 5% interest compound every 2 months. To find the accumulated amount, I use the compound interest formula, which is S equals P multiplied by open bracket 1 plus I close bracket raised to the power of N. Next, I substitute the given values into the formula. The principal amount P is 50,000 ringgit, the annual interest rate is 5%, and the interest rate is compounded 6 times per year because it is compounded every 2 months. The investment period is 4 years. Therefore, the calculation becomes 50,000 multiplied by open bracket 1 plus 0.05 divided by 6 close bracket raised to the power of 6 multiplied by 4. After simplifying, 0.05 divided by 6 equals 0.0083. So the expression becomes 50,000 multiplied by 1.0083 raised to the power of 4. Finally, multiplying 50,000 by 0.2204 gives 61,019 ringgit and 55 cents. Therefore, the accumulated amount in Isma account today is 61,019 ringgit and 55 cents. On to part 2. If Isma decided to add another 12,000 ringgit into the financial scheme today, calculated the total amount of his money after 3 years and 8 months from now, Isma decided to add 12,000 ringgit to the investment. Therefore, the new principal amount becomes 73,019 ringgit and 55 cents. The money will remain in the financial scheme for another 3 years and 8 months. converting this period into years gives approximately 3.6667 years. Using the compound interest formula, S equals P multiplied by open bracket 1 plus I close bracket raised to the power of n, I substitute the values into the formula. This gives 73,019 ringgit and 55 cents multiplied by open bracket 1 plus 0.05 divided by 6 close bracket raised to the power of 6 multiplied by 3.6667. Simplifying the opponent, 6 multiplied by 3.6667 equals 22. Therefore, the expression becomes 73,090 ringgit and 55 cents multiplied by open bracket 1 plus 0.05 divided by 6 close bracket raised to the power of 22. Next, 0.05 divided by 6 equals 0.0083. So, the calculation becomes 73,090 ringgit and 55 cents multiplied by 1.0083 raised to the power of 22. Evaluating the exponent gives 1.2003. Finally, multiplying 73,090 ringgit and 55 cents by 1.2003 gives 87,645 ringgit and 55 cents. Therefore, after 3 years and 8 months, the total amount in ISMA account will be 87,645 ringgit and 55 cents.
An annuity is a series of equal payments made at an equal interval of time. The example of annuity is the shop rental, insurance policy, and installment payment. In each case, equal payments are deposited or paid periodically over time. Financial consultants use annuity calculation to advise people on the investment, and a property agent use annuity calculation to estimate the repayments of housing and car loans. Next, terms. The term of annuity is the time from the beginning of the first payment interval to the end of the last payment interval. A payment interval is the time between successive payments. If, for example, a vehicle is purchased with monthly payments on a 4-year loan, then the term of the loan are 4 years and the payment interval is monthly. First, let's look at the future value formula. S equals R multiplied by open bracket 1 plus I close bracket raised to the power of n minus 1 all divided by I. In this formula, S represents the future value of the annuity. R, it represents the regular payment amount. I is the interest rate per period, and n is the number of payment periods. Furthermore, the interest earned or paid from the annuity can be calculated using I equals S minus NR, where I represents the interest earned or paid. Next, let's look at the present value formula. A equals R multiplied by open bracket 1 minus open bracket 1 plus I close bracket raised to the power of negative n close bracket all divided by I. In this formula, A represents the present value of the annuity, R is the regular payment amount, I is the interest rate per period, n is the number of payment periods. In addition, the interest charged or earned can be calculated using I equals NR minus A.
For question 4a, we need a request to find the value of x, which is represent the amounts where we draw amounts. First, we identify all the information given in the question. The amount deposit is RM26,519.19. The annual interest rate is 40 rates. The information period is 11 years and the interest in compound amounts. Next, we divide the annual interest rate by 12 to above the monthly interest rate. So, 1.14 divided by 12 giving 1.113333. After that, we calculate the total number of months withdrawal by multiplying 11 years by 12 months. Therefore, the total number we withdraw is 132. Seeing this is any annuity problem, we use the present value of annuity formula. Then we substitute all the value into the formula. After simplifying and calculate, we obtain a value of 106.61539. Finally, we divide to RM26,519.19 by 106.615 to find the value of x. The answer is RM248.74. Therefore, Sharif can withdraw RM258.74, even more for 11 years. For question 4BI, we are requested to find the amount of the housing loan. First, we identify the information given. The monthly repayment is RM987.60. The interest rate is 6.5 per year and the loan period is 55 years. Next, we divide the annual interest rate by 12 to above the monthly interest rates. So, 0.065 divided by 12 giving
0.0054167. After that, we calculate the total number of monthly payment by multiplying 55 year by 12 months. Therefore, the total number of payment is 300. Since this is a low prepayment problem, we use the present value of anything formula, then we substitute all the value into the formula. After calculate, we obtain guides RM 146 to 201.06. Therefore, the amount of the housing loan is RM 146 to 201.06. For question 4B2, we are requested to find the total interest paid. First, we calculate the total amounts repaid to the bank. We multiply the daily repayment by the total number of payment. So, RM 987.16 multiplied by 300 giving RM 208,614,788. Next, we calculate the total interest paid. We subtract the loan amount for the total repayment. Therefore, RM 209,614,148 means RM 146,201.02,806 equals RM 148,846.84. Hence, the total interest paid is RM 149,946.94. Question number 4. B3. For question, Sulaiman want to settle the loan in mediation after making the 250 payment. First, we determine the number of payment remains. We separate 250 for the total of 300 payment. Therefore, 50 payment remains. Next, we use the present value of anything formula for calculate the outstanding balance of the remaining payment. Then we substitute all the value into the formula. After calculate, we got RM 43,137.50. Therefore, Sulaiman need to make an addition payment of RM 43,137.14 to fully settle the loan.